Okay, so today we are going to do the last section of chapter 13. It is called gas stoichiometry. Basically, we're going to combine what we've been learning about some gas laws with our good friend stoichiometry from a few chapters ago. So let's get started. Our review word that we need to make sure we remember is coefficient. Remember, that's the number in front of the chemical formula of each substance that gives us a relationship between the reactants and the products. So when you look at this chemical equation here, 2 hydrogen plus O2 gives us 2 waters. Those 2's are the coefficients I was just talking about. You've been taught by me that this equation tells us that 2 molecules of hydrogen react with 1 molecule of oxygen to give us 2 molecules of water. A couple chapters ago when we were doing stoichiometry, you also learned that this equation means that 2 moles of hydrogen can react with 1 mole of oxygen to give us 2 moles of water. Well, now, because of what you learned on Wednesday or Thursday about how moles and volume are related because of Avogadro's principle, we now can look at this chemical equation if everything in it is a gas and relate volume to volume as well. So you could look at this, and instead of just saying 2 moles plus 1 mole equals 2 moles, you could say 2 liters of hydrogen react with 1 liter of oxygen to give you 2 liters of water. Now again, this relationship only works if all of your parts of the chemical equation are gases. So let's look at this. What volume of oxygen gas is needed for the complete combustion of 4 liters of propane? Assume that the pressure and temperature is constant. What you need before anything else is a balanced chemical equation. So for this balanced chemical equation, we take propane, which is a hydrocarbon, and complete combustion means that we would react this with oxygen to always produce carbon dioxide and water. If we balance this, we would need 3 carbon dioxides, 4 waters, and 5 oxygens. So remember, if we just looked at this the way we had it before, this is 1 mole of propane reacts with 5 moles of oxygen to give us 3 moles of carbon dioxide and 4 moles of water. But what I just taught you is that because this is all gases, we can think of this as a liter to liter ratio. So that would mean 1 liter of propane reacts with 5 liters of oxygen to give us 3 liters of carbon dioxide and 4 liters of water. Well, that means we can use that ratio of the coefficients, that mole to mole ratio, the same way in this as a liter to liter ratio. So if we start with 4 liters of propane, we use our conversion factor. Put your words in first. Well, you need to cancel liters of propane, and what we're trying to do is to find out how many liters of oxygen we need. Well, what is your ratio? There's a 1 with the propane. There's a 5 with the oxygen. So therefore, I would multiply this and I would find that I needed 20 liters of oxygen in order to completely combust with the 4 liters of propane that I started with. This just takes us through the answer. Okay, so again, key thing that you need is a balanced chemical equation. Here's another example of a balanced chemical equation where it's a mole to mole ratio is also the same as a liter to liter ratio. That's what they mean by 1 volume. They mean 1 liter, 2 liters. Okay, it's that liter to liter ratio. Let's try another example. Ammonia is synthesized from hydrogen and nitrogen. So here's our balanced chemical equation. If 5 liters of nitrogen reacts completely with hydrogen at a pressure of 3 atmospheres and a temperature of 298 Kelvin, how much ammonia in grams is produced? Now, at first glance, you might just get a little overwhelmed with this and want to give up. Please don't. It's just about working this through step by step. So, if I know how many liters of nitrogen I'm reacting, I can find out how many liters of ammonia I produce. That's just using the stoichiometry. So 5 liters of nitrogen, and you're just using your stoichiometry to find out how many liters of ammonia that is. Remember, we need to cancel out our units. So what is your coefficient with the nitrogen? It's a 1, so you put a 1 down there. What is your coefficient with the ammonia? It's a 2, so that goes up here. So that means I produce 10 liters of ammonia. Now that gives me ammonia, but that doesn't tell me anything about grams of that ammonia. It just tells me the liters. And that would be if we were at STP, but we're not. We're at 3 atmospheres of pressure and 298 Kelvin. So we need to take this volume, put it into our ideal gas law, and find out how many moles that gives us. From there, you can be able to find your grams. So let's try it. PV equals nRT. What's our pressure? 3 atmospheres right here. What's our volume? Well, we calculated it's a 10. We're trying to find moles. Our R, because we're dealing with atmospheres, is 0.0821, and our temperature is 298 Kelvin. There we go. So you're going to just use algebra to solve for nitrogen. So I would divide by this on both sides. And I would find that N equals 3 times 10 divided by 0.0821 divided by 298, and I would get that I have 1.23 moles of ammonia. Well, if I know I have 1.23 moles of ammonia, I again know how to find grams of ammonia. Hopefully you remember this. How many grams equal how many moles of ammonia? Remember, this is that molar mass, so you'd be using that atomic mass from the periodic table. If I have 1 mole of ammonia, nitrogen is 14, hydrogen is 3, so this would be 17 grams is 1 mole. If I multiply 1.23 times 17, I find out that I get 20.9 grams of ammonia from 5 liters of nitrogen. Okay, so that's your lesson for today. Hope you feel confident with it. Hope it makes sense. Your homework is posted on Canvas. If you have any questions, please pop into the Zoom meeting. I'm there from 8 to 11 today, and then I'll be there from about 12 to about 1:30, or you can email me to set up a private meeting time. Have a great weekend. I'll look forward to seeing you either on Monday or Tuesday of next week. Bye-bye.